that have both actually light and electron microscopes. This is a multimodal facility. We call a multimodal imaging facility, and sometimes we can actually correlate the data that come from this facility. Before to go, because they just say that will be good, that we have people from different fields that they don't understand. Don't worry, I'm not going to enter in what all our microscopes and imaging systems do, but I would like to bring up here the people, because I think the people is the soul and the core of the core facilities. I mean, without a good team, without a good experts, it would be very difficult to run a facility like our facility or any facility. And as you see, we have divided the expertise according to the different instrumentation we have in the facility. In one side, we have here all the group. Today, we get her for the first time. We are actually increasing the group. For the light microscopes and on the electron microscopes that gave us a bit more resolution in the images. We have another team, and Erin is also coming quite soon. That's why the picture is not as nicer. Once I have her here, I will take a better picture from Erin. And of course, when you have a facility like that with such a big number of instruments and different formats of images that come in from each of the instruments, you need to have people that helping us on the image processing and the analysis that come up from all these instruments. For the moment, we have Rafael as well there helping us, and he have been one of the ones together with Hayan and Maria and me that have actually working a lot on the remote, in the remote training and remote access. And we actually hope to continue even more, continue doing remote and automating by doing a smart microscopy. And I hope that we will get 1 or 2 more people here, and the team will still continue growing. I'm very happy for that, but it's at the same time a lot of headaches when you have a big number of people. This is just to show you a collage of what we're doing during the day. Of course, we have different microscopes, and we have also wet lab where people prepare samples to go before to the microscopes. We also have instrumentation to prepare in here as well, samples that go for both light and electron microscopies. This is an example of the electron microscopy and scanning electron microscopy. And this is an example of the light microscopy. And as you see already here, because you see that the guys have headsets, is actually because they are actually doing a training to our users. And as the majority of us, this is just to being a bit the mission that we have in the facility, as many of you as well that they are working in facilities. We have to service our users and help them with the design of the projects and support them with the preparation and with the image analysis. We training in our facility, that's why we call them users, and it's an open access, is because we training them to use our instruments, and people run their experiments with our support. We of course organize events or party events, as I'm doing right now, but at the same time, in parallel that we have this eRemote, we are actually running an image analysis course, and I will show you as well what is going on there in terms of the remote. And of course, there is an innovation and method development in the facility. But we go to the remote, that I think is the topic of the day, and I will have today, this is the agenda for the talk. I will do a little bit historical context, how the remote access got and remote training got into the facility, and some pipelines and some demos and examples of where we have done. Our facility, as I say, we are an imaging facility. We are sitting actually in where they call the Sahlgrenska Academy, that is the medical faculty, and actually the facility is sitting somewhere here in between these two buildings. We are actually integrating both. This is where Gothenburg is right now in Sweden. It's a small number of people, but very big, long country. As I say, we are an open access for state-of-the-art imaging equipment. We are open to any research or industry company in Sweden and abroad. This is our website that you can enter. Where we have done it in the normal cases before the COVID that have forced us in a way to go more remote and do the trainings in remote is that we meet our users, we discuss with them for around an hour, we register them in our web core management system, and after we sort of do interactions as well with the users, they start to do interactions with the users with Microsoft Teams. Why do we use Microsoft Teams? It was because the University of Gothenburg have the full Teams, Microsoft Teams. That means that we can use all the capabilities of the software. And why do we went? Of course, as the majority of you, they started, we already have some remote access to the microscopes, but it was not a routine. Now we have more routine on trainings online, but we started, of course, in 2020, once the COVID came to us, and even so that Sweden didn't have a strong lockdown and people can walk around and go out, we have to keep a social distance. That means that we need, and our rooms where our microscopes are far too small to actually be in the same room, two people, for at least 2 to 3 hours. That's where an on-site session normally take. Then we have to pass and we have to set up the training online. And here is just an example of our whiteboard where we're discussing how do we actually have to deal with that, and which steps and what do we have to do. As we just heard, it's always a bit difficult, and we have to break the ice more when we have a digital, whatever it is, remote access or remote training, or even with the colleagues discussions. Is the same when you actually have to do a training, where we notice, of course, that the trainers have to focus more and have to be more active and motivating the trainees constantly during the training. As we said, we use the remote, the Microsoft Teams that we install in our microscopes, and then we're sitting at the microscope and connecting with the user that was sitting in their lab or in their home or whatever they were, and have a direct connection with the microscope. The Microsoft Teams as well allow us with the desktop to actually control, if we want, that the user itself have as well the possibility to control the microscope. That's not possible in every microscope, but in majority of them, they will allow us as well to do some remote control of the microscope. To be able to display much better the mouse. As you see, the mouse here is quite small. We actually use the keystrokes for the mouse clicks, and that was quite good for the user to know and to follow up exactly where we were at the particular moment on the training on the microscope. But before to start, of course, we have to send a user quick guide to the software itself for the program of the microscope, but also how everything will work with the teams. And we did testing with the users beforehand, and that they actually see that the whole session work. And they have, of course, we try to tell them that they need to have a good screen, a good connection, good audio, that they can help us, and we were testing all that before actually the training happens. And during the first session of the training that is online, at some point we need to have some on-site visit, because of course we need to train in them how to switch on and on the microscopes and how to put their samples on top of the scopes. But during the online sessions where we did, it was a slice in a PDF where we had the theory, because on the training we just not only train how to use where to click in the software, but we give them as well a basics in microscopy and some to understand why you need to use a particular objective and what is the difference in between resolution and magnification and so on. Then there's, as I said before, the trainers have to be more prepared and have to constantly motivate the trainee, that even if they don't ask the questions, we actually ask the questions to them to keep always the momentum and the nice discussion among us. And here is just an example. This is Rafael, and here as well. I mean, actually, sometimes we have one person that do the training. He's sitting at the microscope, as you see here, and here is the stroke where you can follow up, and you know that we are activated. There is a user in the other side of the microscope. This is just the program that run in the instrument, and we have a second person as well following as well either to help and to help the first training, or as well to learn from each other. And that was very, very convenient. The staff were sitting and hear each other and helping each other in what can be improving or not. And in the other side, of course, we have the users following us. And this is just a small video.
On the left, you have a tool that says mean region of interest.
Now you will hear Rafael discussing and explaining exactly.
Then, you can here go to the bottom where it says mean region of interest. You see that there is different tools.
We explain the user actually how to choose a region of interest.
And I go to where my sample is and I draw a rectangle. Right? And now the interesting things comes. You will see on the left, this is how the intensity changes over time. And this is if you actually want to see the numbers are there. But the most important thing for me is to see that the line is very flat. And that means that my laser power is quite safe for this sample, and I'm not bleaching my DAPI stain.
Okay.
Why? Because I scan 10 times, one after the next, and I always got the same, more or less the same value, right? If my sample would have been very sensitive to the laser power, you would have seen this line dropping.
Okay, down, yes.
Exactly.
Interesting.
So, this is a convenient tool that I usually tell people that they should check if they want to know if the sample is, it's okay or not for the laser power that they are using, right?
Okay.
All right.
Okay, so that was just an example of how we actually did the training with our users. Where we notice on that is that they actually the user itself was more focused on the program, and once we have the next training on site, that we also mix on site online actually to avoid to stay 2 hours or 3 hours with the user. They were actually more prepared. I'm more prepared because, as you see, I just showed you 1 minute of a presentation, but actually we have 2 or 3 hours of full training, and these videos was given to the users. That means they have extra material to go over and over again on the program. That means, and we actually are using now this material to training the users beforehand. I mean, once we are going to have a training in nowadays that they are more on site, even so that we still keep some online training, but the majority is already on site. We actually have used this material with the users and tell them, look at this beforehand, and it actually made their life easier for the trainer. And actually the user get much faster how to use the microscopes. We also have worked with the remote. Once we got some instruments that also allow us to remotely control the instrument, we actually have done as well that. If you want to see more, I mean, this is a video from the Cell Discovery 7. That's a microscope that we have. It's like a box where we can do high content screening. If you want to see more the video, I will not bring it now. We have it in YouTube, in our YouTube, and there you can see the full remote and description of the remote instrument control. Of course, here have to be trained users. It cannot be a beginner for using the equipment. We can register in the facility, and they have to be, of course, actively booking the microscopes and know the microscope very well. And together with our IT, we have actually used the VPN rights to give access to this. And I remember in one of the meetings that we had before with the Euro-BioImaging on eRImote, Johanna have the possibility to touch the microscope from Germany to Sweden, or at least click into in the program and control the microscope from